Don't rush to throw away your old soldering iron. Have you ever wondered how many useful tools get discarded just because one small component fails? This old soldering iron may look completely useless now, but today we're going to give it a completely new purpose. The last time this soldering iron was used, it still worked normally, but after sitting unused for a long time, it suddenly stopped heating completely. Now let's plug it in and confirm the problem first. The tip is pressed against this foam surface, but nothing happens. No heat, no smoke, no reaction at all. Normally, most people would throw it away immediately and buy another one. But if you look closely, the outer shell and handle are still perfectly usable. So instead of replacing the entire tool, we're going to rebuild it into something completely different. First, all the internal components need to be removed. The old heating system is no longer useful, so the internal parts are slowly pulled apart one by one. Small screws, burned wires, old heating elements. Most of these parts no longer have any real value, but the outer housing itself is still strong enough to become the foundation for a new tool. Now comes the most unusual part of this project, a spark plug. At first, this probably looks completely unrelated to soldering, but spark plugs are actually designed to survive extremely high temperatures and electrical stress inside engines. The ceramic body is highly heat resistant, while the internal metal core allows electricity to pass through safely, and that makes it surprisingly suitable for this rebuild. Now, the wire connection needs to be prepared first. Using wire cutters, the outer insulation is removed carefully to expose the copper core inside. Then the copper wire is wrapped tightly around the end of the spark plug. Slow twisting movements, pulling the wire tighter each turn. Because electrical conductivity depends heavily on strong contact pressure, loose connections create resistance, unstable current flow, and unwanted heat buildup over time. Once the wire is secured properly, it gets fed through the original metal tube from the soldering iron housing. At this point, the spark plug already starts looking like part of the original tool, but there's still a small amount of looseness around the body. And even small movement later can weaken the entire structure during use. So now a simple piece of tissue paper becomes surprisingly important. The tissue is wrapped carefully around the spark plug body to remove the empty gap inside the metal tube. Then superglue is applied slowly over the tissue layer. The paper absorbs the glue almost immediately, and once it dries, the material becomes extremely rigid and durable. It almost feels like a hardened industrial spacer instead of ordinary paper. Now the spark plug sits firmly inside the housing with almost no movement at all. At this stage, the handle can finally be reattached. And honestly, the rebuilt tool already starts looking surprisingly complete. Next, the remaining wire gets connected to a large alligator clip. This clip will become part of the electrical connection system later. The exposed copper wire is wrapped tightly around the metal connector before being clamped firmly into place. A clean electrical path matters here because unstable current flow can reduce performance significantly. Now we still need another wire system for the negative connection. So here I prepare 2 more alligator clips and another piece of wire with a different color to avoid confusion later. Both ends of the wire are stripped carefully. Then each end gets attached to an alligator clip. Slow squeezing motions with pliers, making sure the copper strands stay compressed tightly inside the connectors. And now we finally have 2 separate conductive paths ready for the power system. Before moving further, I'm curious where everyone watching is from. Do you still repair old tools where you live? Or do most people simply replace them now? Feel free to share your experience in the comments because I always enjoy learning how people repair things in different places around the world. Now we move to another very important component, the carbon rod. Here I have an old 1.5-volt battery that no longer works properly. Even though the battery is dead, something useful is still hidden inside. The outer metal shell gets removed slowly, and inside we can finally see the carbon rod attached to the positive terminal. This part is actually very fragile, so it needs to be pulled out carefully to avoid cracking. Now the carbon rod still contains a little electrolyte residue from inside the battery, so it gets cleaned and dried first before shaping begins. One end of the carbon rod now needs to become the working tip of the new soldering tool. So instead of sanding it by hand slowly, we can use the rotation of a drill to speed up the process. The carbon rod spins rapidly while sandpaper gradually shapes the tip. Fine black carbon dust starts appearing immediately, and little by little the shape becomes sharper and more precise. A tip like this is much better for concentrated electrical contact later. Now the spark plug and carbon rod finally need to be connected together. A small copper connector bridge is used between both components. Once tightened into place, the entire structure suddenly starts looking like a real custom-built electrical tool. But there's still one important problem left. The ceramic body of the spark plug is designed to insulate electricity. That means the current cannot naturally travel from one end to the other through the outside surface. So now we need to create a bypass path manually. Using a short piece of wire around 10 centimeters long, electricity gets connected directly from the upper terminal of the spark plug down to the lower connector near the carbon rod. This wire becomes the actual conductive bridge carrying current toward the carbon tip. Without this connection, the tool would never work properly. And honestly, this is the moment where the whole system finally starts making sense. Now comes the first real test. The rebuilt tool gets connected to a drill battery for power. The negative wire touches the battery terminal carefully. Then the carbon tip approaches a small metal clip. and immediately a bright electric spark appears. Strong, fast, extremely concentrated, which means the rebuilt tool is finally working. Now let's see if it can actually join metal together. Two razor blades are placed side by side. As soon as the carbon tip touches the metal surface, the heat builds up almost instantly. The metal begins melting together surprisingly fast. Honestly, it's hard to believe this tool started as a completely broken soldering iron and a few discarded materials from around the workshop. An old spark plug, a dead battery, some leftover wire. And now all of those forgotten parts have become a completely different tool with a new purpose again. Sometimes the most valuable part of repairing things is not saving money. It's learning how much hidden potential still exists inside objects most people already gave up on. Thanks for watching, and I'll see you in the next video.